Hey everybody, Jim Neeb again. I just finished another round of RapidChange ATC testing. So the purpose of this round was to just put a lot of cycles on it and see how reliable it is. Both repeatability, just getting jams or errors, as well as, do things wear out. A lot of people, including myself, had concerns about the way this thing grabs the nut, and the fact that you're spinning the collet with the spindle to loosen it and tighten it would maybe wear out the collet. So I put last weekend I put about 300 load unload cycles on this across 6 different collet bit combinations. So I think I gave it a pretty good workout. I'll show the new software procedure that RapidChange added to the macros. Initially I got about 2 or 3 total cross thread incidences when I used it for about 100 cycles, and they felt like that was too much. They made some adjustments so that now, instead of spinning up the spindle and dropping it in, they just put it in to push the nut down a little bit, then they spin it up once. That kind of pulls the nut in. The idea was that it would help hold the nut down flat. What I found was that helped probably about 50%. And then the other cause of my problem was I did not have the magazine perfectly aligned. So it was off about 10 or 15 thousandths on this end versus this end, so that the way this works when you do the setup is you give it the XY coordinates of your number 1 pocket, and then it knows, you also give it the spacing depending on what size collet you have. The spacing of all these pockets is different, so it knows where the 6th one is just by adding up those spacings, but it should be right down the y-axis, and mine wasn't, and that's what was actually causing most of my cross threading. So in all of my cycle testing, basically what I got it in the end dialed in so that I didn't have any errors in 100 cycles. The couple things, my little tube here fell off once or twice. This is a little piece of shrink wrap tubing, and what it does is I have my door open most of the time, and I have outside light coming in, which has a lot of infrared content, and that floods the infrared sensor that detects whether or not the collet is properly mounted. So if that falls off, I immediately get an error. That's not the fault of the RapidChange. That was just me bumping it when I was playing around with this 6th pocket. The other one I get sometimes is not all of my collets grip the bit well enough to always keep it in position. So if you exercise this for maybe 25 cycles, there's a decent amount of vibration that happens when you're unmounting and remounting these. So after about 25 cycles, I have a couple of collets, mainly this one that's in here in the spindle right now, that don't hang on strong enough when it's not tightened. I have a few that I'm not even using at all because they won't even hold the bit in. So that's my biggest challenge right now, is finding collets that, when not tightened, hold the bit strong enough. Like this one's pretty good. I can put it in the right position and it'll stay. My 1/2-inch one has a very good grip on that bit, so no problems there, which is good because that's a pretty heavy bit. 1/8-inch bits are not a problem. They're so light, they tend to hang on. But I've got a couple of 1/4-inch collets and a 3/8-inch collet, and it's just the way they are. Like you get some bits that they could easily be 6 thousandths under their nominal dimension, and then you can get a collet that's machined maybe slightly higher than it should be. There's just no friction fit there, and they can slide out easily. That's my only issue right now, is finding collets that grip. I do have a set of 6 here that worked well enough for the testing, so I was able to get through that. The So I haven't, so like I said, I got down to easily being able to execute 100 cycles with no issues after I did that final alignment. So those are probably the 2 or 3 key tips. I don't know if RapidChange is going to start putting some kind of a shield tube on this sensor or not, but you can easily do that. Like I said, just a little piece of tubing with some super glue to hold that in place. The second one is get some collets that you know will hang on to the bit when they're not tightened on. And the third is to make sure you get your cart magazine mounted very accurately the long ways down your axis, and then obviously when you set it up in the first place, you want to get that first position XY as accurately in the center as possible as well. But once I did that, I didn't have any problems. I did have early on a couple of fail to unloads. That was primarily my fault too. I had about the same RPM for load and unload set in the settings, and what I found was 1400 RPM was a pretty good load RPM, and then I bumped it up to 1600 for the unload, and that gives it just a little bit more unload power, and I didn't have any unload errors after that. So the system is very reliable. One thing that's really nice is that the checks, once you have the IR beam set up at the right 2 heights, basically there's a height to detect when the collet nut is in place, and then it does another check at the very bottom to make sure it's threaded on properly. It will catch fail to loads, fail to unloads, miss threads 100% accurately. Because I've had, in all of my playing around with this, I've had quite a few of those different things based on me not setting this up correctly mostly. And sometimes if the bit falls out inside your magazine, because I do have one that's a little bit too loose, what happens is it'll screw on the collet nut properly, and then when it comes over to do the touch, it'll come down far enough where it hits the maximum length that I have programmed in to allow for that, and it'll throw an error there. So the system is very robust as far as things that can go wrong. It will catch them. So I've never had a problem with it, like, you know, not picking up a bit, doing a touch off, and then going and trying to cut, or not every single one of my cross threads, every single one of my unloads, and every single one of my drop bits have been caught 100% by the error detection. So that has been a pleasant surprise, that beam across there is that accurate. And the other thing is, a lot of people were concerned about cross threads, and I was too. I've had quite a few now, mostly because of my misalignment in here, and I probably cross-threaded this thing a dozen times. I have yet to feel a burr or see any damage at all on either of the collet nut or my spindle. It's not enough RPM when it's loading at 1400 to do any damage. I think this metal's just very hard, so you know, that's not really a concern either for me anymore. So the other thing I did was I did some torque testing today. Basically, I would load a bit and then use the torque wrench with the other wrench up tight against the frame. And what I found was, now with the double tap that it's doing and running it at about 1400 RPM for load, I get between about 14 pounds and 20 pounds of torque on the nut. It seems to be collet dependent. I've got like this big 1/2 inch one, I get well over 20 pounds with that one every time. Some of the smaller ones can get down to around 14 pounds. The hard part is to know whether or not that's enough. If you look online, the recommendations are all over the place. You can see clearly most of the maximum specs are around 50 to 60 pounds for the ER20s, But that's a maximum spec, and there's no way anybody gets that kind of torque when they're setting these unless they're using a torque wrench in a holder or something, because with a 6-inch set of wrenches, a 60-pound torque means you're putting 120 pounds of pressure on these, and that's just ridiculous. So besides measuring them between 14 and 20 pounds, I also did a round where I compared them just to how I normally tighten them by hand, because to me that was more valuable. I've been using this machine for about 5 years, and I have a good feel for just how much torque I normally put on these. And I've only lost bits or had bits move on me in use twice. They were both my fault. One of them I didn't notice was a damaged collet. It was all scratched up and had burrs inside. The other one was a case where I ran the smooth part of the shank along some wood, and this thing heated up extremely hot, and so everything swelled up and got loose, and the bit started to come out. So with my normal hand tightening and proper use, I've never had a problem. So I compared the torque I was getting with, like, if I would squeeze it like I would normally do I have to squeeze it a little bit more? And about half of the time I had to squeeze it just a bit more, but not really much. I was comfortable with that. It would have stayed in place. And then, like I said, with a couple of these, I had to squeeze a lot more than I normally do to get it to move any tighter. So I'm thinking at this point it's enough torque, but I have the one more test I want to do is do some cutting tests where I load it in the collet with the ATC, do a really heavy duty load, like I'm going to plow this bit through some mesquite, and then go and cut a flat top on the wood, and keep doing that and stepping it over and see if it ever moves after I do another deep cut that really loads the bit down. That's the best thing I can think of doing. It's really just it's the last ditch thing I can do to see if it's going to move, but I really don't think they're going to, just from taking all the torque measurements I have and comparing to how I normally hand tighten. I'm pretty convinced that there really isn't going to be any issues, but I just wanted to do that as kind of one final test. So I'll have one more video with kind of a final wrap up and some of that testing. But so far, at this point, I'm very happy with the reliability of the system when it's set up properly, as well as I'm going to show you in a minute here what the nuts look like and what the inside of this looks like after. I've probably got 350 total cycles on this between the active cycling and just some messing around. So I'm going to show you that next. Now it's going to push it down in the socket, then spin it up. And then it does a double tap to do the tightening. So that's the part that's different. It's instead of spinning up once and then lowering into the nut while it's spinning, it gets centered first and then spins it, backs off, and then double taps it. This has improved the cross-threading somewhat. And the second part of the cross-threading improvement was me getting the magazine perfectly aligned with my x-axis or my y-axis. So the first thing I want to do is I just look down in these holes to see if there's any debris, any metal pieces. They're very clean. There's nothing left in there. There's no plastic being ejected out of these pockets. There's no pieces of ball bearings. There's no pieces of my collet nuts. One thing I wanted to point out I didn't make real clear last time is these are the 3 sockets that I originally damaged that I mentioned in the first or probably the second video when I accidentally ran the RPM way too high. I was running at 6,000 instead of 1,600. So I got some new replacements here, and I also got replacements of the new style. So if you order one now, you're going to get the new style, and what you can see is the hole is huge compared to the original size. So with this, I can actually run a bit that's almost as big as the collet. You can see the rim down in here is very minimal, just to make sure the nut doesn't fall through compared to the old one. So, and they increased the spring size. So I can do, for example, I have a set of these Amana cutters, and I can now run the 45 and the 60 degree bits. I can't run the 90 or the 120. Those are really massive V bits, but these two now I can run, which I'm really pleased about because those are bits I use a lot. So now when I look at the size, I don't really think that's much of a limitation with the new design, because most people don't run bits bigger than an ER20 collet head. Now, you know, if you do a lot of surface planing and stuff, that's not true, but RapidChange is actually working on something for those really large bits as well. So I went through all of these and kind of felt, you know, after about 300 cycles, were these ball bearings. These are what catches the flat part of the nut when it's dropped in there to both load and unload. And these are all good. They're all protruding like they did originally. So I'm pretty happy about that. So they all have about 300 cycles. This part that is down in here is very easy to replace. It looks like this is the old style one with the small hole, but the other one looks the same with a bigger hole. It's just a 3D printed part with 3 ball bearings. So if, you know, you use this thing for years, I'm sure it can wear out eventually, but the cool thing about that is you just take the top off and you can replace these. I don't know what RapidChange charges for these, but it's, you know, it's a pretty minimal part, so I'm sure it's not expensive. And really, like I said, the nice thing is that's really the only part that would wear out on this. And it's easy to replace, so that's nice. Now, looking at the nuts, you know, a lot of us were concerned about how bad are the edges of these nuts going to get beat up, because you're basically dropping these in. So this one and a couple of these, I can tell these are my old ones because they have the blue top, whereas like this one's a brand new one. I bought these later to do more extensive testing, and the ones that have the edges a little bit, the finish is taken off of them. Those are the ones that I ran at 6,000 RPM earlier by accident, and that actually didn't do much damage. I mean, it took the finish off, but there's really no burr or anything on there. They still, you know, like I said, you can tell they're shiny now, but really not any significant, no functional damage at all. These newer ones have 300 cycles on them, and it hasn't even taken the finish off of them. You know, so this is what they look like after proper use, when you only have 1,600 RPM and 300 load-unload cycles. Well, actually, each one of these would have about 50 unload cycles, load-unload, because I did the 300 cycles across all 6 of these. But, you know, 50 times these got spun in and stopped against those ball bearings, and the finish is still on them. So I'm not at all worried about the threads anymore. I'm not at all worried about the collet nuts. I'm really not concerned about these the pockets prematurely wearing out. What I found was a lot of people said, hey, why use this kind of soft plastic cover? It's basically, I don't know, it's not neoprene, but it's a pretty soft material for the lid. It actually turns out that was a really wise choice. It's pretty tough. You can see a couple of circles on the top here. This is where I did something stupid and got fat fingered with the MDI window or just jogging, and I actually lowered This one here, I think, was the one I lowered it down onto a chuck or onto a collet when I forgot to open the lid first, and it actually stopped the Z stage without cutting through this. So this stuff is extremely tough. So I think it was a wise choice. This was me a mistake as well, where I lowered it down accidentally and punched a bit through the arm. So it's still working, which is kind of amazing too. So you know, I did a lot of testing on here. I slammed some bits into the side. This HDPE is super strong stuff. You'll actually snap a bit off if it's a 1/4-inch bit before you damage this magazine. So it's a lot better once you've got it set up and you're not screwing around like I was. You want to basically get it set up and then just use the macros, and then you don't really have much risk of running into the side or anything. Whereas I was messing around trying to get my alignment and doing some other testing to see, you know, what happens if there's no bit in there and things like that. And so I had a few accidents, and the thing really stood up well to that kind of abuse. So kind of surprised about that. So I guess that's it for this round. So far so good. My last thing is kind of a final. Does it hang on to its bit? Can I make it come loose with some really extreme cutting? And then I'm going to do an actual real project with it. My daughter asked for it that needs a few different bits to do the job. So that should come in the next week here, and then we'll be done. I'm ready to basically put this thing into use and move on. If you have any questions or comments, and if anybody knows of a source of collets that have a little bit more snug fit than usual, I would love to hear it, because that is my number one issue with this right now. Is I don't like to just buy collets and try them. It would be nice if they would hang on when they're not tightened, and I haven't found anybody that advertises, you know, undersized at all. So would love to hear about that if somebody has any information. Thank you.